Hey guys, and welcome back. It's Savannah, your application scientist from Thermtest. We are at the Nanomaterials Lab at the University of New Brunswick for part 2 of our investigation of the impact of nanoscale entrapped oxygen on the thermal conductivity of 3D printed metals. Even though the 3D printed metals have similar density to their solid counterparts, the presence of oxygen or other entrapped gases affects the heat flow within the materials. The nanoscale gas has a lower thermal conductivity than the metal matrix itself. Thus, oxygen content correlates with the reduced overall thermal conductivity, especially noticeable in metal 3D printed samples. In part 1, we measured the thermal conductivity of a few common solid metals used in 3D metal printing. They were measured using the MTPS sensor available on our advanced MP-1 platform. Today, we're going to repeat these measurements on the 3D printed metal samples. The method used for printing these metals was selective laser melting, which utilizes a high-power laser to selectively melt and fuse powdered metals or alloy materials layer by layer to create a complex and precise 3D part. Again, we're using the Thermtest MTPS sensor following ISO 22007-7 to measure thermal conductivity at different timescales, investigating metals for homogeneity. Stable thermal conductivity at different penetration depths would suggest that the sample is homogeneous. We are going to use the same testing schedule built in part 1 for testing the 3D printed parts and the identical sample setup. Now, we're going to walk through the basic sample setup of the MTPS sensor. So now we have a 3D printed stainless steel 316 sample that we're going to be measuring on the MTPS sensor. So to set it up, it's the exact same as the solid steel. You just set the sample over the sensor, centered, and then use the provided weight to ensure good contact between the sample and the sensor. And now we can move to the software to start our schedule. So back in the scheduling page of our software, we can again select the method to be modified 3D disk source when using our MTPS sensor. Next, we can set our operator ID, as well as select a save location for our test results. Moving on to the sample page, when you select the port that the MTPS sensor is connected to, it's going to automatically fill your backing material. So then we can enter our sample name. In part 2 of this series, we will be measuring the 3D printed stainless steel 316. Our sample height was measured to be 12.5 millimeters with a radius of 25.2. So next we can check the sensor resistance before moving on to the scheduling page. Okay, excellent. So in the scheduling page, we can click this little plus button to add a new schedule line. In the new schedule line, I'm going to select the ITPS, which is our Intelligent Transient Plane Source feature, which automates parameter selection for you. As a user, all you have to input is the sample name as well as the sample dimensions, and it's going to optimize your test time and power for you, making measurements extremely simple and straightforward as a user. So our test time and power is optimized. I'm going to leave the number of tests as 5 with a delay of 10 minutes in between each test. And then to start the schedule, I'm just going to click Start. So now we can move on to the analysis portion, where we will be comparing the results of the solid stainless steel to the 3D printed stainless steel. As well, we ran a few measurements on titanium, so we'll be comparing solid titanium to 3D printed titanium. Here, we present the results of thermal conductivity measurement for 3D printed stainless steel and titanium samples using the MTPS sensor. Measurements were taken at various times and plotted against probing depths for each sample. We found that the thermal conductivity of the 3D printed samples was significantly lower compared to that of the solid samples shown in the previous video of this series. This reduction is expected due to the presence of entrapped oxygen particles within the 3D printed samples. To confirm this, we compared the densities of the solid and 3D printed samples and observed that the 3D printed samples had much lower density. This lower density correlates with the higher concentration of entrapped nanoparticles, which effectively reduces their overall thermal conductivity. Along with other patented advancements, we continue to strive for the intelligent MP-1 to be at the apex of thermophysical instrumentation. If you have any questions or want to see your own demo, please contact us at info@thermtest.com, or with the information, click the link in the description below.